Hey you guys, welcome back. Today we're going to go over multiplying and dividing fractions. Before we do that though, food review of the day. I got this Trader Joe's hot honey popcorn. So it's popcorn, it should be sweet and spicy. So we'll see how it goes. Open it up. Smells good already. So there's a ton in there. They do fill it up. Trader Joe's is not stingy. Let's see how it goes. Mm. It's supposed to be hot honey popcorn. That means like spicy and sweet. This really just tastes like kettle corn. It just tastes really sweet. There's not really much spice. A little bit. I mean, it's pretty good, I guess. It just tastes like sweet, just like the honey's on there. It's like they forgot the spicy part. This bag. Mm, I don't know. It's okay. I give it like a 5. It's all right. I mean, I'll probably have some more later, but it's really just okay. You know what? You could skip this if you go to Trader Joe's. It's not great. So let's go over this. So we're going to do multiplying and dividing fractions. Whenever we multiply and divide fractions, this is usually every kid's favorite because multiplying fractions is usually the easiest one. So let's look at the first one. Let me get the pen going. Where is it? There we go. Whenever we multiply fractions, we don't have to worry about denominators, multiples, nothing like that. All we're worried about is multiplying across the top and multiplying across the bottom. So 1/3 times 3/4. All we're going to do is multiply the numerators. 1 times 3 gives us 3. And multiply the denominators. 3 times 4 gives us 12. Now, if we can simplify, we have to, always. I can't give you full credit if you don't simplify. So 3 over 12 simplifies down to 1/4. That's because the greatest common factor here is 3, so I could divide them both by 3 and end up with 1/4, okay? But if you forgot about simplifying, you could still get most of the credit for that problem. The next one, same thing. I'm going to multiply the numerators and then multiply the denominator. So 5 times 2 gives us 10. 6 times 3 gives us 18. Now, even if you can't think about what the greatest common factor is to be used to simplify a fraction, if both of the numbers are even, you know no matter what, 2 goes into them. And sometimes we simplify in steps, and that's okay. So let me divide them both by 2, because I know they're both even numbers, so 2 is a factor. So 10 divided by 2 gives me 5. 18 divided by 2 gives me 9. And that can't simplify any further, so that's my final answer, 5/9. Now let's look at this one. This is negative 1/4 times 2/5. This is where middle school and 7th grade specifically comes in and makes it a little different than all the stuff you did in elementary school. Sometimes the fractions are negative. So let's multiply the numerators. Negative 1 times 2. You do have to remember those negative rules. We get negative 2. 4 times 5 gives us 20. Now, if we can simplify, we must. So they're both negative, or they're both even numbers. Even though this one's negative, they're still both even numbers. Every even number can be divided by 2. So we end up with negative 2 divided by 2 gives me negative 1. 20 divided by 2 gives me positive 10. So I'm left with negative 1/10. In case you forgot, if there's a negative number, you can put it wherever you would like in the fraction. You can keep it with the numerator, which is what I usually always do. You can keep it with the denominator, which sometimes you may see. Or you can keep it with the fraction bar, which you also may see. But keeping it with the numerator is probably the most common. Let's look at the next one. 3/10 times negative 1/5. I'm going to multiply the numerators. 3 times negative 1 gives me negative 3. 10 times 5 gives me 5. 10 times 5 gives me 50. What am I saying? Negative 3 over 50. Now you have to think, is there a number that goes into 3 and 50? There's not. The only numbers that could go into 3 are 1 and 3. 3 does not go into 50. In case you don't know how to tell if a number is divisible by 3, meaning that if a 3 would go into a number, you could take those digits of the number, like here, 50. If you add up the digits, like you break them up, 5 plus 0, I get 5. If whatever answer you get when you add those individual digits is a number that 3 goes into, then it's divisible by 3. Otherwise, it's not. Take, let's see, what's another one? 72. What if this was negative 3 over 72? Maybe you don't know if 3 goes into 72. Take those individual digits. 7 plus 2 gives me 9. You're going to add up those digits. If the number you get is divisible by 3, meaning does 3 go into that answer, then you know it's divisible by 3. So 72, 3 does go into. 50, 3 does not go into. So because of that, this is my final answer. I can't simplify it any further. Look at the next one. Negative 4/9 times negative 3/8. Negative 4 times negative 3 gives me positive 12. Those negative rules still come into play now, so you do have to memorize them and have them at least as good as you can, okay? I have some little anchor charts in here that do help, but the more you have them on top of your head, the easier all this math becomes. So we get positive 12. 9 times 8 gives me 72. Oh no, this is kind of a tough one. 12 into 72. So I'm going to think, let me see. First of all, does 12 go into 72? And it does, because I got 12, 24, 36, 48, 60, 72. It goes in there 6 times. I could divide both of these by 6. And that'd be great. But you know what? Those numbers are big. Maybe you can't think of 12, and you don't know that that goes into both of them. So you know what? They're both even numbers. I could divide them both by 2, and I can simplify in steps. So let's divide them both by 2 because they're both even. I end up with 6 over, let's see, 72 divided by 2. So that'd be like, what is half of 72? That's going to be 36. 6 over 36. Oh, you know what? They're both even again. Let me divide them by 2 again. I end up with 3 over 36 divided by 2. So 36, what is half of that? That's going to be 18. Oh, so these are not even. But you know what? 3 goes into both of those numbers. So I could divide by 3. Divide by 3. And I end up with, let me write it down here. 3 divided by 3 gives me 1. 18 divided by 3 gives me 6. So 1/6 is my final. But you know what? Instead of doing all that work, what if I had just divided by 12 and divided by 12? I would end up with 1 as the numerator and 6 as the denominator. You end up with the same answer either way. This, dividing it by 12, is just fewer steps and saves you time, okay? But don't worry if you need to divide by 2 every time. You're more worried about getting it right than saving time. That's better. Getting it right is always more important. So let's look at the next one. Negative 4/5 times negative 1/8. We're going to multiply the numerators. Negative 4 times negative 1 gives me 4. 5 times 8 gives me 40. Let's see, I know 4 goes into both of those, so I can divide them both by 4 and end up with 1/10. All right, let me give that an erase and let's scroll down. Let me get that going. All right, let's look at the next ones. Now, these are all division problems. Multiplication is everybody's favorite because it's usually the easiest for most kids. Division is everybody's second favorite because it's the second easiest typically, mostly because we're going to turn all of these division problems into multiplication problems. The way we're going to do that is through this. Now, we always say keep, change for subtraction into addition. Whenever we do division, we're going to do this one, keep, change, flip, all right? Or the mathematical word is this, reciprocate. So you may hear that, and you'll hear it as you get older and take more advanced math classes. We're going to keep, change, flip, or keep, change, reciprocate. And that just means that we're going to flip the fraction. So if we had 2/3, we would flip it and use 3 over 2. That's the reciprocal whenever we flip a fraction. What if we had a negative, though? What if we had negative 3/4? If we wanted to flip that fraction and take the reciprocal, we could do 4 over negative 3. So you can keep the negative with the denominator. That's totally fine too. Or just like what I would always do, I would always keep the negative with the numerator. And I would write negative 4/3. Remember, as long as you have one negative, you can put it anywhere in the fraction that you would like. And it still remains a negative fraction. So let's go and do a few of these. 2/5 divided by negative 4/5. I'm going to go and rewrite this. 2/5, I'll keep it. We're going to change division into multiplication. We're going to flip or reciprocate the second fraction. So instead of negative 4/5, I'm going to have negative 5/4. Now we're going to multiply straight across. 2 times negative 5 gives me negative 10. 5 times 4 gives me 20. And I just have to worry about simplifying. This simplifies down to negative 1/2. So I could divide them both by 10. Look at the next one. 3/8 divided by negative 9 over 10. I'm going to go and rewrite it. Keep the first number the same, change division to multiplication, and flip or reciprocate the second fraction. So instead of negative 9 over 10, I'm going to have negative 10 over 9. Now I'm going to multiply the numerators. 3 times negative 10 gives me negative 30. 8 times 9 gives me 72. This is one of those other problems. It's kind of hard to see what would the greatest common factor here be. I know they're both even. I know no matter what, I can divide them both by 2. It might take me a few steps, but that's okay. Negative 30 divided by 2 gives me negative 15. 72 divided by 2, let's see, what's half of 72? It's going to be 36. Now I'm going to think of that thing we said a few minutes earlier. If I can add the digits, like 1 plus 5 and 3 plus 6, if they give me a number that I know 3 goes into, then I can divide them by 3. So they do. 1 plus 5 is 6, 3 plus 6 is 9. So I know 3 is a factor here. I'm going to divide them both by 3. And I end up with negative 15 divided by 3 gives me negative 5. 36 divided by 3 gives me, let's see, 10 would be 30, 11, 12. Negative 5 over 12. I can't simplify further, so that's my final answer. Let's look at the next one. So I'm going to go and multiply. I'm going to rewrite it as a multiplication problem. Keep the first number the same. Division becomes multiplication. I'm going to flip the second fraction. So I end up with negative 2 times 7 gives me negative 14. 7 times 4 gives me 28. And that's going to simplify down to negative 1/2, because I could divide them both by 14. That's the GCF, the greatest common factor there. Next one, I'm going to rewrite it as a multiplication problem. Negative 1/12. Keep it the same. Division becomes multiplication, and then flip the second fraction. So I end up with negative 1 times negative 3 gives me positive 3. 12 times 2 gives me 24. Now I'm going to simplify it down to, let's see, 3 goes into both of those, so I can simplify it down to 1/8. The next one, keep the first number the same, change division to multiplication, flip the second fraction. So now I have negative 1 times negative 12 gives me positive 12. 6 times 5 gives me 30. I could divide by 2 because I know they're both even numbers. I get 6 over 15. Oh, and these are both divisible by 3, so I could divide them both by 3 and end up with 2 over 5. 2/5. The next one, now this doesn't have a denominator, but every whole number, even if it's negative, still has a denominator of 1. We just don't have to write it. So I'm going to rewrite this, negative 5 over 1. Keep that number the same. Change division to multiplication. Flip the second fraction or reciprocate it. So now I have negative 5 times negative 2 gives me positive 10 over 1. And if any number is above 1, that number is really just a whole number. And we don't have to write that 1. We never have to write the denominator of 1. So that number is just 10. There we go. All right, you guys, thanks for sticking around for the whole video. Again, multiplying and dividing is great. When we're multiplying fractions, we just multiply the numerators, multiply the denominators. We don't have to worry about multiples and finding common denominators and all that stuff. With dividing fractions, we use that keep, change, flip method. So we keep the first number, change division to multiplication, and then flip the second fraction. You guys, thanks for sticking around for the whole video. I'll see you guys in class tomorrow. Bye.